Motor speed. When looking at a motor, there are two different types of speed. The first one is the synchronous speed. This is the speed of rotation of the rotating magnetic field, and it's calculated as Ns is equal to 60 times the frequency divided by P, where P is the number of poles. P is the number of pole pairs. In other words, what I usually do is I count either the north poles or the south poles. The second type of speed is the rotor speed. The rotor speed is the actual speed at which the rotor is rotating, the actual output speed of the motor. It's calculated as Nr equals Ns times 1 minus S, where S is the slip, Ns is the synchronous speed or the ideal speed of the motor, and that will result in my rotor speed. Now slip is the difference between the actual rotor speed and the synchronous speed. S is equal to Ns minus Nr divided by Ns. Okay, this is expressed as a percentage value. Basically what it does is every cycle, because the synchronous or the rotating magnetic field is pulling the rotor around, due to loads and losses on the rotor itself, it is going to rotate at a slower speed than the rotating magnetic field. Considerations when selecting a motor. When selecting a motor are primarily the torque and the duty cycle. Okay, the torque is the strength of rotation of the motor. What is that motor going to require? Are we going to need a constant torque? Are there going to be gradual changes? Or are the changes going to be sudden or abrupt? In other words, is there going to be quick and regular changes? Then the duty cycle refers to the duration of use. In other words, are we going to have this motor as continuous? Are we going to have it run for hours on end, or are we using it as intermittent? In other words, regular start and stops. And if we do so, what is the torque requirements for that motor? Now, when it comes to the motor speed, as I said earlier, the load will influence the speed, because the speed is dependent on the slip. Now what happens is, when we've got the rotor inside its magnetic fields, when we place that rotor inside the magnetic field, the rotating magnetic field runs at a certain rate. The rotor rotates slightly slower because of the load. But now what happens is, as the slip increase, the difference in the speeds between the synchronous and the rotor speed, NR versus NS, as that slip increases, the torque of the motor will increase proportional to that load which is causing the slip. In other words, the rotor speed wants to be as close as possible to the synchronous speed, but the further the slip, or the greater the slip is, the more the torque will be. So greater load will decrease the speed, but it will increase the torque of the motor.